Close your eyes for a moment and try to picture the biggest thing you can imagine. Maybe it is a mountain. Maybe it is an ocean. Maybe it is the entire Earth itself. Now forget all of it. Because what we are about to explore is so incomprehensibly large that every single thing you have ever seen, touched, or thought about fits inside it and takes up almost no space at all. So here is the question: how big is the universe, really? Not in a vague, hand-waving way, but truly, honestly, as far as science can tell us. The answer is stranger than you expect, and it gets stranger the deeper we go. Let us start small, relatively speaking. The Earth is about 13,000 kilometers across. The Moon sits roughly 380,000 kilometers away. That sounds like a lot. If you drove there at highway speed, it would take you about 6 months. The Sun is further, 150 million kilometers away. Light, the fastest thing in the universe, takes about 8 minutes to travel from the Sun to your eyes. 8 minutes. Remember that unit, because we are about to start using light as our measuring tape. 1 light year is the distance light travels in a single year. Almost 10 trillion kilometers. It is not a unit of time, it is a unit of distance. And from here the numbers get very large, very quickly. The nearest star to our Sun is Proxima Centauri. It sits 4.2 light-years away. If you launched a spacecraft today using our current fastest technology, you would arrive in roughly 70,000 years, and Proxima Centauri is our neighbor. The Milky Way, our galaxy, our home, stretches roughly 100,000 light-years from one side to the other. 100,000 years of travel at the speed of light. There are an estimated 200 to 400 billion stars in the Milky Way alone. If you counted one star every second, it would take you over 10,000 years just to count them. And we are not at the center. We are out in one of the spiral arms, about 26,000 light-years from the galactic core. A quiet suburb of a vast, slowly spinning city of stars. Now here is where your brain starts to protest. The Milky Way is not alone. It sits inside a group of galaxies we call the local group. About 80 galaxies in total, bound together by gravity, spread across roughly 10 million light-years. Our nearest large neighbor is the Andromeda Galaxy, 2.5 million light-years away. When the light hitting your eye from Andromeda on a clear night first left that galaxy, our ancestors were just beginning to use stone tools. You are not looking at a galaxy. You are looking 2.5 million years into the past. The local group is itself just one small cluster inside something called the Virgo supercluster. Hundreds of galaxies spanning over 100 million light-years. And the Virgo supercluster is just one small piece of an even larger structure called Laniakea, a massive supercluster of galaxies containing an estimated 100,000 galaxies stretching 500 million light-years across. Stop. Sit with that for a second. 500 million light-years, hundreds of thousands of galaxies, each galaxy containing hundreds of billions of stars. Each of those stars potentially surrounded by planets. And Laniakea, this almost unimaginably vast structure, is still just a small corner of what we can observe. When astronomers map the large-scale structure of the universe, they find something remarkable. Galaxies and galaxy clusters are not spread out evenly. They form long threads and walls, called filaments and sheets, with enormous empty voids between them. The whole thing looks, honestly, like a cosmic web, or like the structure of neurons in a brain. The largest known structures in this web, called superclusters and great walls, can span several billion light-years. Now we hit a hard limit. There is a boundary to how far we can see, not because the universe ends there, but because of how light and time work together. The universe is approximately 13.8 billion years old. That means light has had 13.8 billion years to travel toward us. In theory, we can only see objects whose light has had enough time to reach us since the Big Bang. This boundary is called the Observable Universe. But here is the twist. Because the universe has been expanding the entire time that light was traveling, the actual radius of the observable universe is not 13.8 billion light-years. It is closer to 46 billion light-years. That gives the observable universe a diameter of roughly 93 billion light-years. 93 billion. Inside that sphere, Astronomers estimate there are somewhere between 1 and 2 trillion galaxies, each one containing hundreds of billions to trillions of stars. The number of stars in the observable universe is estimated to be around 1 septillion. That is a 1 followed by 24 zeros. There are more stars out there than grains of sand on every beach and desert on Earth, combined, by a factor of roughly 10. Here is the part that makes it even harder to hold in your mind. The universe is not static, it is expanding. Every moment, the fabric of space itself is stretching, pushing galaxies further apart, and the expansion is accelerating. Something is driving this acceleration. We call it dark energy. We do not know what it is. It makes up an estimated 68% of the total energy content of the universe. It is the dominant ingredient in the cosmos, and it is almost completely mysterious. Because of this expansion, there are galaxies we can see right now whose light will never reach us again. They are already moving away from us faster than light can cross the growing gap between us. We are not just looking at the universe, we are watching ourselves slowly become more isolated from it. So the observable universe spans 93 billion light-years. That is what we can, even in principle, ever observe. But is that the whole universe? Almost certainly not. Most cosmological models suggest the universe extends far beyond our observable horizon. Some models suggest it is at least 250 times larger than what we can see. Some inflationary models suggest it is effectively infinite, or so close to infinite that the distinction barely matters. The total universe may contain regions we will never see, never measure, never even detect. There may be galaxies out there, trillions of them, that are forever beyond our horizon, racing away faster than their light can ever reach us. The universe we see is not the universe that exists. It is just the tiny slice of it that time and light have allowed us to glimpse. Back to the question, how big is the universe, really? The honest answer is this. The part we can see stretches 93 billion light-years in diameter. It contains more galaxies than you could count in 1,000 lifetimes, more stars than grains of sand on every shore of Earth, and more potential worlds than our imagination can begin to contain. And that is just the observable slice. The real universe, the full thing, is almost certainly unimaginably larger, possibly infinite. Here is what I find most remarkable about all of this. We are small, extraordinarily, almost absurdly small. A single human being on a single planet orbiting a single ordinary star in the outer edge of one galaxy among 2 trillion. And yet, we looked up. We built instruments. We studied light that took billions of years to arrive. We measured the age of time itself. Something this tiny looked out at something this vast and started to understand it. That might be the most surprising fact of all. If you want to keep exploring, there is a question that follows naturally from this one. If the universe is this large and contains this many worlds, why have we never heard from anyone else out there? That is a question for the next video, and the answer is deeply unsettling. Make sure you are subscribed so you do not miss it.